Hello everyone. Now we're going to see the task scheduler thing in the heaps playlist. This is probably the last question. And after this, we're going to see the implementation part, the heapify, the heap sort, max heap implementation, min heap implementation, and all of such stuff. So if I come to task scheduler, what does the question statement say? The question statement says that you'd be given a character array that would represent your tasks, and that would be of size n, right? That would be of size n, right? And then you would tasks could be done in any order. Each task is done in 1 unit of time, and you'll also have a cool down period. Like, what does a cool down period says? That if I have three tasks, okay, A and B, and the cool down period, let's say, is given as k is 2. If the cool down period is given as 2, if the first task is done right here, I have to keep the two blocks idle within and then do A. So this could be taken by B and this could have to be kept idle. I hope you're getting it. Let's just see the example. And we don't have to return an order, but also we don't only have to return an order, but also the order that takes the minimum of the total time of the CPU. So we have to return the least number of unit of times that the CPU will take to finish all the given tasks. I hope it's making sense to everyone. Let's just quickly see this example that says we have the given tasks as triple A, triple B, and the cooldown period, that is K, is given to us as 2. So if I start with A, these two spaces I have to leave blank and then do A. So this space can be taken in by B, and then this space can be taken by B. So 1, 2 spaces, 1, 2 spaces, and this by B, and this by A. Makes sense? So this spaces we have to leave idle. Okay. Now there's a catch that you will understand in this example. I hope it makes sense. So here we have 6 A's, 1B, 1C, 1D, 1E, 1F, 1G, right? So if I start with A, I have to leave 1, 2, 3, 4, 5, and 6. And then, sorry, case 2. I'm so sorry. Okay. I start with A, I have to leave in 2 spaces. I start with A, I have to leave in 2 spaces. 5th A, and this is 6th A. Make sense? Then B. B can come in, C can come here, D can come here, E can come here, right? F can come here, G can come here, and then these I have to keep idle. I hope it makes sense. Right. Now, if the same question, if let's say I have A as 5, B as 2, and C as 1, right? And if I start filling it up with B, so it would be B, 2 spaces, B, 2 spaces. Make sense? And then I have A. So I keep in A. I keep in A. And then 2 spaces, I keep in A. 2 spaces, I keep in A. 2 spaces, I keep in A, and C can be kept anywhere, right? So I've got 1, 2, 3, and 4, 5, and 6 idles. Now if I start with A, 2 spaces, 2 spaces, 2 spaces, 2 spaces, then with the 5 is, yes, start with B. 2 spaces, B here. C, right? Idle, 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 idle. So it takes 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Are you getting this thing? So the thumb rule, this is see 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 3, 6, 9, 10, 11, 12, 13. And here you'll be seeing very minimal difference that okay, it's a one slot difference. But the minimal answer you'll be getting when what do you do? When you take in the tasks that are taking the maximum frequency and fill up the slots. Fill up slots with tasks having max frequency. And this is the thumb rule. Make sense? Okay. Let's just once try if I start with C. So if I start with C in the same question, C, I don't have anything else. I'll just put in B. 2 spaces left, I will put in B. A, 2 spaces, A, 2 spaces, A, 2 spaces, A, 2 spaces, A. Fifth A is the last A we have, right? How many? 3, 6, 9, 12, 15. And now if this A was, a larger number, let's say A was 10, A was 11, the difference could have been very much visible. I hope you're getting it. What is the thumb rule? The thumb rule is to start always with the task that has maximum frequency, give it its duration, give it its slots to be filled in, and then fill it up with the other left ones. I hope you're able to get something, extract something out of this, right? Let's just now start with the coding part basically, and then I believe you'll be able to understand it a little bit more going forward, right? So what do we have to return? Least number of units of nines. So if I have to, I'll just change the pen real quick. Yeah. So if I have to return the least number of units of times, I will have the return type as integer. Make sense? Least interval. What are we given? We'll be given n number, k cooldown period, and a vector of char, that is array. That represents what? That represents your jobs. I hope this is making sense. And then, first, what do you do? So at first, what you have to do, you have to see the question in which it says that n tasks. You have the n tasks. All these by let it be A, B, all these are character driven. Then you have a cooldown interval k. So between each task of the same type, let's say A and A, you have a cooldown period that this much time slot should be there before you start another instance of the same task. Makes sense? That is the cooldown period. So you want to schedule all the tasks in such a way the total time is minimized, but you have to respect the cooldown period as well. Right? I hope it makes sense. So at first, what do I have to do? I have a vector char array, right? From this example, let it be this. A small example I'll take. So I'll take the example A, basically, B, B, C. So what do I have to do? Let's just find out the frequency because I am telling you that I will start with the maximum frequency element. So let's just have a map and have the frequency of every element stored up. Make sense? So to define a map, I'll use unordered map, char and int. Char is for your job and int is for your frequency. Let's call it MP. And then I will just iterate over your given job array and MP ka, sorry, MPRI, this is plus plus. Make sense, everybody? Onto this? Yes. So after I have this map, what do I have to have? Now your most frequent tasks, that is going to be dynamic, right? And when I have this done, and every time when I have to find the most frequent task at every instant, what do I use? I am going to use a max heap. Let's just define a max heap. A max heap will be defined with your priority queue. Now I don't have to tell which which job is executed where. I don't have to give an order. I just have to tell how much time units is it going to take in an completely to complete this many tasks of this many tasks of this, and so on and so forth. So I don't have to return the order. If I don't have to return the order, I don't care about the job. I just know, okay, this slot is occupied. We'll see this more again. But here you need to know, why am I not using uh, first always has to be int, because that is where the sorting will be done. Why am I not using this? Because I don't need to return which slot is, occupied by which job. I just have to return that, okay, there is a slot and that has been occupied. Make sense? So priority queue max heap. Then you just have to run it over your map. So to run it over the map, to iterate it over map, I will use auto itmp. Makes sense? And then you will just push into max heap. Now this is your, here it is char and your frequency. I need only frequency. So max heap dot push it dot second. I hope it is going to make sense for everyone. Why am I doing this? Right? So this has been done. Now my max heap is also defined. Now there is something as K, cooldown period. So I need to have a queue. And now why am I telling you queue and why not stack? Why not anything else data structure? Because see, the first instant I use the most frequent task at first. So I am going to go append this to my queue that, okay, now after K time, this job can be taken up. Right. And after that, I take some other task that has most frequency. So my first task in the queue. So what is queue? Whatever you push in inside the queue, the last would it be to be taken out, right? So the first thing you're pushing in, right? The first thing you're pushing in is the first thing to be taken out. Makes sense? So if I'm pushing a task first, it will be taken out first. And that is what I want. I want it a sequential. Because if something was, if a task was carried out at t is 1 second, so it will complete its cooldown period faster than the task which was executed at t2. Make sense? Just see. Now let's suppose at T1, I executed task A and the cooldown period, let's say, is just 2, right? So now A task is here. Make sense? Now at T2, I executed B task. B task is here. So at T3, I executed, let's say, C task. C task is here. Now at T4, what should be taken out? A task. Makes sense. So it is first in, first out structure because B will not have completed its cooldown period until T4. So the first task that needs to be taken out is A. I may not have to take out anything is another case that like at T2, when I go in through, I will not have anything to take this out because it will be completing its cooldown period at what instant? 1 plus 2. Makes sense? If T1A was there, 2, 3, nothing. Here I will have, right? So it will be completing its instant at 4. So until 3, I will not have anything to take it out from the queue. But at T4, I can only take out the first added entry and not B, not C. So the first in and first out. That is why what do I use? I use queue for my cooldown management. I use queue for cooldown. So how do you add it in the queue? You add in your what? You add in your time available and frequency remaining of the task. Let's say a task. Now a task was a task took part at 1, right? Let's say we are using indexing 0 based, because otherwise you will have to +1 if you're not using 0 based indexing. So let's just go simple. Now a task was executed at 0 level. Okay, make sense? Now I say my cooldown period is 2 seconds. My cooldown is 2. So 0, and then when it can be taken up, it can be taken up at 0 plus k. Make sense? So what do I have to push? I have to push k. And then frequency. Because if this is finished, let's say once I have executed a task, I have to decrease its frequency by 1. So that its frequency, when it reaches 0, I do not take it again into account. So what does your queue has? So what does the queue has? Queue has a pair of what? Int and int. Make sense? And let's just call it queue. The most easy, it's most easy to name a queue, just mention it queue. As simple as that. Okay, then what do? I have to define my time as 0. Makes sense, right? And then I have to run this until both my max heap is not, until my max heap does not get empty or my queue does not get. So if there is any of the element in either of these, the while loop has to keep running. So if my max heap is not empty, that is, I have an element that is most frequent. So what am I going to do? What does my max heap contains? My max heap contains only the frequency. So I have to just take int frequency, let's say max heap dot top element. Make sense? And then you have to pop it off. And then what? You have to decrease the frequency. Make sense? And after decreasing the frequency, what do you have to do? You have to just push this into queue. And why will you push it into queue? If your frequency is greater than 0, then you have to queue dot push. What would be your first element? The first element you're putting in is your time. When can you take this out? So you can take this out at t plus k. Right? Time plus k. And what is its frequency? Its frequency is this. I hope it made sense. Right? So your if loop is this. Now we will see if my queue is not empty, right? And also my queue is not empty, and also the first entry that is there in the queue can be taken out at this instant. That means the first task that is there in the queue that was executed first has completed its cooldown period and now can be taken out. Does that make sense, right? So I have to now release my cooldown tasks. How do I do this? I have to say if my queue is not empty, right? And what is queue? Queue's first thing is remaining time, and here it is frequency. And queue dot front, right? Queue dot front dot first is greater than sorry. Your queue dot front dot first, right, is less than equal to your time. And you can push this through max heap so that again you can check it on the frequency part. So when you're pushing it to max heap, you have to push only what? Q dot front dot second, because that is where you have your available frequency. Q dot front dot second. Make sense? And then you have to pop it from the queue. That part is a little non-tricky part, right? And now if both of these things you couldn't do, still what you have to do, you have to go and increment your time in every turn. That is the most important thing. Make sense, everybody? On the same page, are we there? So what do we have to do then? What do we have to return is the question right now. So your while loop, this while loop ends up here, and then we return howsoever time slots were taken, returning time. Make sense? So that is your code. I think we're good with it. This is your code, right? This is your code. So I think we're good with the part of the code. Yeah. Now let's just quickly see up to the time complexity analysis. If you have any doubts, any concerns with the explanation, with the problem statement, with anything, just use the comment section. Else, I have also dropped in the Google Forms link in the description. You can use that also. You can let me know of any question you want me to take in that could belong to heap, that could not belong to heap. Anyway, I'm going to solve that question. So yeah. Let's just quickly see your time complexity. So while this, you were building your heaps. Let me just change the pen. While this, you were building your heaps. This took O of n time, right? Because array size is, this array size is n. Your array size is n. Okay? Make sense? Then when you are pushing into heap, now let's say m is what? M is the unique elements. Unique tasks. Okay. So while I was pushing into your max heap, this was O of m. Make sense? Oh, sorry. O of log m is for 1. So what is for m elements? It becomes m log m. Make sense? Right. So while we are pushing or popping from the heap, it is also taking your n log m. For 1, we have log m, but then you have n tasks, because every task, howsoever many times it is there, you're taking it out from queue and pushing it into heap, right? This thing. So every time the element is there, it is like if you have n tasks in your actual array, n times at most, this is each single task is getting like in total you're getting n pushes, at most n pushes, so you're getting it. Are you getting that? And then your each task is also pushed popped from queue once, right? When I'm talking about queue, so whenever you're pushing into queue, you're popping from queue. It takes O1 operation for push and pop. So when you're doing it for n times, you give it O of n. Make sense? So if I add all this, sorry. If I add all this, you have O(n), O of m log m, O of n log m, then you have O of n. So this goes around O of n log m. Make sense? Why? So where n is your total tasks. That is to say, you're given input size, and m is your total unique tasks. I hope everybody is good with this, right? Hopefully. Should be, if anything. Yeah. So if you have any doubts, if you have any concerns, please use the comment section. Please use the GForms link. If you were able to extract 10% of the video, 20% of the video, if you found the video helpful, go like in the video, subscribe the channel because I'm getting more videos in. With this, yeah. With this, I think I'll take your leave. Thank you so much. Bye-bye.